Hello, hello to everyone. I hope that you are doing well in your school internship. So here it is our starting of our online sessions where we are going to resume our studies via online. So this is our video that will help us or will help you to continue studying your mathematical concepts where you are going to revise and continue to progress to the another concept. Some are already covered, another we are going to start the new ones. So we know that we are in unit 1, we are still dealing with complex numbers. So this is the concept we have already talked about in our face-to-face sessions where we have seen that we have talked about the concept of the complex numbers. Uh, Not on this one and their algebraic forms. Uh, in this case of concept of the complex number, it is just to remind you what does it mean, the concept of the complex number. We say that this complex number, we can say let z concept. We can say that our complex number z is equal to a plus bi, and we say that this where this a is a real part and this b is imaginary part. Now, and this a is imaginary number. Now, this is our description of our complex number, and in this case, this is the form algebraic form of the complex number, where here we used to say that our complex number, set of complex number, it is composed of a plus bi, where such that a, b are in a set of all real numbers. It means those are real numbers, and also we know that I square is equal to negative 1. This is a set of the complex number. That just is to remind you what we have already talked about this concept of the complex number and its algebraic form. So not only this one, but also we talked about the properties of this our imaginary number. So in a imaginary number, this imaginary number, we have seen that this imaginary number I, we have seen that this I, it's our imaginary number. We can say that I power n, where n is in a set of all real, it is in a natural number. It is a natural number, it means it starts from 1, n starts from 1, you can start from 0, 1 up to infinite. And then if you remember, we can find that I power 1, I power 2, I power 3, I power 4 up to n. And we have seen that about those properties. We have seen that in the case of I power 4 n, always it is equal to 1, and I power 4 n plus 1, we have seen that if you can simplify it, it is equal to I. In the case of 4I n plus 2 is equal to negative 1, and the case of I 4n plus 3 is equal to negative I. This is the properties for the imaginary number I, and we normally use them to find the number in the complex number. So this is just to remind you about the properties of this imaginary number I, Another thing is about geometric representation of the complex number. Our complex number z, which is equal to a plus bi. We have seen that while we are presenting this complex number in an Argand plane, we used to draw the Cartesian, the Argand plane, and this Argand plane, we say that this axis is for real part, and this is for imaginary axis. And we say that here you can have, for example, our for z, here have a and here have a b, and this is our steps. It is 0 and I. So our z, we can represent this z as z is equal to a plus bi. This is the case for representation. While we are representing in the Cartesian plane, in the Argand plane, this complex number, we use this case of Argand plane. Then we represent imaginary for real part. We take the number in the real part, then our number in the imaginary one, the real one where it meets is the point, and we call it our complex number z. Now, not only that, but also even operations. In operations, we have seen that we have addition, we have subtraction, we have also division, we have also multiplication of the complex numbers. We can relate that z1 be one complex number and z2 be another complex number. And if we say z1 plus z2, we add imaginary numbers and we add their corresponding real parts. We add the imaginary parts of the first complex number with the imaginary part of the next another complex number, and also we add the corresponding real parts of the real part of this z1 and the real part of this z2. In this case also we have not only for addition and also for subtraction, where you can subtract z1 from z2 from z1. Also we subtract accordingly. So we take the imaginary part of this one, we subtract it, this imaginary part of this another complex number z2, and also we subtract from the real part of this one with the real part of this z2. It's just to remind you, then you can apply your own exercises and revise the notes. So we have seen also the case of multiplication, where you can multiply z1 and z2, where we have seen that you multiply by following the rule of multiplication. For example, if you have a plus bi times c plus di, we follow the order of multiplication, where I add a times c, have ac plus a times di is a di plus bi plus this one, it is c bi, then bi di, this I it is I square, and the I square is equal to -1. So in this case you have a negative bd. Then you continue, you can add this one with imaginary one and this the real parts, then you combine it together to have AC minus BD, then plus AD plus CD, CB, then I, for the case of multiplication. So we have also the case of the conjugate. The conjugate of this complex number. the conjugate of those complex number we have, it is just to remind you that in a given complex number z, which is equal to a plus bi, we say that its conjugate is denoted as z bar, and it is equal to a plus bi, sorry, minus bi. This is our conjugate of this z number complex number z. So in this case, we say that this is just to remind you. For example, if z, let's say this z1, z2 equal to x plus yi, its conjugate will be equal to x minus y minus yi. So this is just to remind you about the conjugates of the complex number. Another case, it is about the modulus of this complex number c. The modulus, if you have a z which is equal to a plus bi, its modulus, it is denoted by z in this way. It is the distance from this point, from the origin to the point, or to this complex number z. Then it is equal to a squared d plus b squared d, then square root. So this is its modulus. Then the last one we have to talk about is about the locus and the square root of the complex number. So this is just to remind you about what we have already talked about in our face-to-face classroom. So apart from that, we can see the topic of today, where we are going to talk about solving equations in a set of complex numbers. So the main idea of those complex number, it is to help us to solve some questions which are not possible to find their solutions in a set of all real numbers. For example, in the set of all real number, we know that we have x squared d plus 1 is equal to 0. In this case, in the set of real number, in the all real number, we solve that x squared is equal to -1. And if we find this one, the case now become a challenge, and we say that x is equal to square root of -1. And sometimes in the set of all real number, it doesn't exist. And we say that it is impossible. But in the case of the set of in a complex number, we are going to have the case to solve this kind of equations. Now, how to solve this one? So we bring the concept of solving this kind of equations. So we have a lesson today, equation in a complex numbers. So those equations, we might have different equations in a set of complex number. We can have a linear form or linear equation. In the linear equation, it is the same as for the set of all real numbers, where we say that in this case we are going to have az plus b, which is equal to 0. So, and in this case, a must be different from 0 so that we can have the value of z. So, in this case, this is z is our complex number. We are going to find this complex number that satisfy the condition to be equal to 0. In this case, as we use it to find the value of x, it is the same as we use it to find the value of z. And in this case, we say that its a solution, it is defined by as az is equal to -b. And then we say that this implies that z will be equal to -b over a. And we solve that solution will be equal to -b over a. This is our solution for this kind of equations. For example, it is just simple. We can solve some examples. Then we continue. For example, we can have examples. let's say for example, find the value of y. Let's say use z for example. If we can find the value of z if 4z plus 5i is equal to 12 minus I. So we can find the value of z. It's the same as in a real number. We use it to find the value of x. But in a complex number, we find the value of z. This is the same. This case, let's say solution for this one. Let's solve for this case. Now we are going to have 4z, which is equal to, you can take this one this side. Then it is equal to 12 minus I, then minus 6i. So here we found that we can add those imaginary ones. This is 5. Then now we have a 4z, which is equal to 12 minus 6i. In this case, we find that our z will be equal to 12 minus 6i over 4. And this implies that z, our z, we want to find it is equal to 3. It is equal to 3 minus 3 over 2i. So this is for the value of z, or you can solve here. Then you can write the solution of z, where you find that is negative 3 or 12 minus 6i over 4. It's the same. Now this is for the example, for the case of this question. We can find also the second one. The second, find the value of z if 2z plus 6 is equal to 0. Let's say solution. We can have that 2z plus 6 is equal to 0. This is equivalent to 2z is equal to negative 6, and z will be equal to negative 6 over 2. And this is equivalent to, this implies that z will be equal to negative 3, and our solution will be equal to negative 3. So this is for the case of this in the set of the complex number when we are solving the linear equations. It means the linear equation, if it is a linear, we say that is a linear if they have a power 1. It means our variable z, it have a power 1. And if it is a power 1, in this case we say that it is a linear equation. So the more exercises are in your notebook, you can try to find more exercises and try to solve them. Then we shall meet and we solve. If there is any challenge, you can request and we try to solve it as much as possible. So not only this one, we can continue to another case of the equation, solving equation which is a quadratic equation. Let's see some quadratic equations. So for quadratic equation, for quadratic equations, we have two cases. So we have two cases. In the quadratic equation, you have two cases. You have a first case where you have, in the quadratic equation, you have a z squared plus b z plus c, which is equal to 0. And for this case, we can find have first case where, for example, a must be different from 0 and b if it is equal to 0. If we find that b is equal to 0, in this case, we remain with the coefficient of a, this is z square, it is there, and the coefficient of z, only z is 0, and we remain with this is c. Now, we can say that for the case where a is different from 0 and b is equal to 0, we remain with a z squared plus c, which is equal to 0. In this case, it is just a simple, we solve as we solve ax squared plus c, which is equal to 0. We use it to solve this x squared in the case of as we solve this case where we solve normally, we find this value of x squared. Now, in this case, we find this z, we solve as z squared will equal to negative c over a, and this implies that z will be equal to square root of negative c over a. And you have to note that I squared is equal to negative 1. So that is all. So for the case of this z squared, which is equal to negative c over a, and we say that it implies it to be z will be equal to square root of negative c over a. And in this case, we can have some examples. So we can say that, let's have an example for those cases where we normally say that it is not possible for the set of all real number. You can say that z squared plus 1, which is equal to 0. Now, we can solve this one. Solve in this set of complex number, this kind of equation. Let's say 1. So, solution for this question, you can say that z squared plus 1 is equal to 0. This is equivalent to that z squared is equal to negative 1. And this implies that z will be equal to, z is equal to negative 1 square root. And the square root of negative 1 in the set of all real number, it is not possible, but we know that I squared is equal to negative 1. It means that z is equal to square root of I squared. Then we say that also z will be equal to square root of plus or minus I. And the solution for this case, this equation will be equal to plus or minus I. That's the first equation. Another one we can do, we can try the second one, we can try 2z squared plus 8, which is equal to 0. We can solve this one in a set of complex numbers. We say that 2z squared is equal to negative 8, and z is this equivalent to that z squared is equal to negative 4. And in this case, this is equivalent to z is equal to this is equivalent to z will be equal to negative square root of negative 4. And you know that this negative 4, I squared is equal to what? I squared is equal to negative 1. The same as to say that z is equal to square root of 4 I squared. And normally this will be equal to, this will be equal to, z will be equal to 2I plus or minus. Now we say that solution for this equation will be equal to plus or minus 2I. That is the case of solving quadratic equation of the form where we say that a is different from 0, b is equal to 0, remain with a z squared plus c, which is equal to 0. And in this case, we normally say that it is very simple. Now you have seen how to solve those kind of equations, and you are able to solve more than those questions you have tried to solve. So this is just to guide you how you can solve different questions in your self-study discussions. So let's see another case. We can have also the case 2, the second case. The second case for quadratic equation, this quadratic equation where a is different from 0 and b also is different from 0. Even c should be, c is a constant, it can be 0 or not. So now our equation becomes, so our equation becomes a z squared plus bz plus c, it is equal to 0. It is the same as we solve ax squared plus bx plus c is equal to 0. We use different ways. You can use completing square, you can use synthetic division, you can use factorization, you can use different methods so that you can solve this one. You can even use quadratic formula. So for this case, as we know that quadratic formula can use determinant where b squared is equal to b squared minus 4ac, and you say x is equal to that one. So it is the same even in the set of the complex numbers. In the set of the complex number, it is the same where we say that we find a determinant, and the determinant is equal to, it is the same, b squared minus 4ac, and we found this z is equal to minus negative b plus or minus square root of determinant over 2a. This is how to find our z. So we have two z's when it depends to the our value determinant. So there is different cases we might have in solving our equations. In our equation, when you have, for example, if we have conditions or remarks. Now, first one, if determinant is greater than 0, it means it's positive. So z we are going to have two distinct roots, or two real roots. Let's say real roots. We have two real roots. It means our z is going to be equal to this one. So we have a z1 which is equal to negative b plus square root of determinant over 2a, and z2 is equal to negative b minus the square root of determinant over 2a. And there is a case, second, it is if determinant is negative. And if it is negative, we have, in this case, in the real number, we say that it is not possible. But when it is negative, it is possible. We have two complex numbers, and those complex number are, it means now z is equal to negative b plus or minus square root of determinant I, then over 2, that is negative, over 2a. It means then we solve the case. We have two complex numbers. And another case, the third one, is if determinant is equal to 0. So if it is equal to 0, we have a z1 which is equal to z2 and is equal to negative b over 2a. It means this case is 0. It means we remain with this case on this one only. And we say that our two z's are, we have two solutions, and where z1 and z2 they are equal. So the remaining is for examples, but the main idea about solving this quadratic equation, it is this one. We can use also factorization. You can factorize and you find the solution. You can even complete square, then you find the solution. That is all. So let's try some examples. Then we see. So let's solve. Let us try to solve different equations in a set of all real numbers. Here we have some examples. Examples. Example 1. Solve in a set of the complex number. The first equation is 1. The first one is z squared plus z plus 1 which is equal to 0. And now let's try to find a solution for this case or this equation. We can think of this one. So first you have to explore those coefficients of our z and constant c. Now from this one solution we have a is equal to what? A for this case is equal to 1, b is equal to 1, and c is equal to 1. Now if a is equal to 1, b is equal to 1, c is equal to 1, we can so find our determinant. Let's use a determinant formula. So determinant will be equal to what? It is b square minus 4ac. And if determinant is equal to this one, we can find determinant will be equal to b is equal to 1, that's 1 square is equal to 1, then minus 4. AC is equal to 1, then the main is equal to this one. So now determinant will be equal to negative 3. So if determinant is negative 3, we are not going to say that is not possible. It is possible in a set of complex number. Where we have seen that z is equal to negative b is negative 1 plus or minus square root of negative 3. And negative 3, we know that I square is equal to negative 1. Now, instead of having negative 1 here, we are going to have I squared. And now we have over 2. 2a is equal to 1. So this implies that is equivalent to z will be equal to negative 1 plus or minus I square root of 3 over this 2. Now this is our solutions. So now solution is r negative 1 plus, let's say, minus square root of 3 I over 2, and negative 1 plus square root of 3 I over 2. That is the solution for this kind of equation. Another, we can find another one. You can solve it yourselves, then you see what you can get. Let's solve another one. Let's solve, for example, 2. Let's solve z square, 3z squared plus 10 which is equal to 4z. For example, let's solve this. Now, this is the second equation. We can react on the first one, then we solve the second one. Now, solution R. First, a is equal to 3 b is, we can write this one as 3z squared minus 4z plus 10, which is equal to 0. And you find that b is equal to negative 4 and c is equal to 10. Then determinant is equal to b squared is 16 minus 4ac, that is 3 times 10. Now this is equal to what? This will be equal to, this will be equal to what? This is a 16 minus 2 120. So this is 12 over that one. Then we get determinant which is equal to 1 negative 1 104. This one. Then we try to find if it is negative. We can find there are two complex numbers. So now this is equal to, we find that this is equal to what? It means that this is our z will be equal to negative b. B is negative 4, that is 4, plus or minus I square root of 104 over 2. Then our solution will be equal to, 4 minus square root of 104 I over 2 and 4 plus I square root of 104 over 2. So that's the solution for this equation of complex in the set of the complex numbers. We can have another one example so that the remaining you can do it yourself. This is just to guide you how you can attempt those kind of equations in a set of complex numbers. Let me check for another one if we can solve it. Then we call it a dash. Let's try this one. If you have finished, okay. Equation 3. Equation 3 solve in a complex number. In the complex number z squared plus 2z plus 3 which is equal to 0. Now let's solve this one. First you have to find our coefficients. A is equal to 1, b is equal to 2, c is equal to 3. Now determinant will be equal to b squared is 4 minus 4ac minus 4ac. We can have this one minus 4ac. All are negatives. Let's use a plus, for example. This is a negative, then here we have a negative. Then negative 4 AC, this is a negative 3, 1. Now, here determinant will be equal to, that is 4 plus 12. And determinant is equal to, determinant will be equal to 16. So, and you say that this implies that determinant square root of determinant is equal to 4. Now, we are going to have a story or root. And now this is equal to, z is equal to negative b. Negative b is negative 2 plus or minus square root of this one, that is 4 over what? Over 16 over 2, for it is over 2. Now this is equivalent to that z will be equal to we can have by plus, we have a 2 over 2 which is equal to 1, that is z1, then z2 will be equal to negative 6 over 2, that is negative 3. Now that is the two real roots, and the solution is equal to negative 3 and 1. Now those are the sample of equations we use to solve any set of the complex number. It is not only the equation in the quadratic, even in the cubic, even in the power 4, even in the power 5, even in the power 6, even in the power 10. The way we use to solve those equations in the set of all real numbers, they are the same way we use to solve in the set of complex numbers. The how we use by factorization, the way we use synthetic division, it is the same we apply them in this case of the complex numbers. What you have to note, it is this one. This helps us to solve all equations related to the complex number, and you have to find that to know that z is equal to a plus bi. All of those equations related to complex number, any equation, any equation, it should be solved by using those two properties. This property is very essential, especially when you find that is not just, it cannot work as in a set of all real numbers. Then what we want from you, please find your textbook and so try to solve those equations you have in your textbook, and try to solve. This is guiding you to solve those equations, and those equations you are solving, you have to refer to this video. And also, if you meet with any challenge, please let us know, then we shall help you to solve as much as possible. So we are here to help you, and we wish you all the best. So we can stop here. Another lesson we shall resume next time. And if there is any question, you can write in the comment, then we can talk together, then we can solve it as much as possible. So thank you very much. See you next time.